Hey everyone, welcome to the Explainer. So if you're gearing up for the Class 4 MEO oral exam, I know exactly what you're feeling right now. The pressure is absolutely on. You see, the examiners, they don't just care if you've read the textbook. They really want to know if you can retrieve critical, life-saving safety data when you're under pressure. So today, we're doing something a little bit different. We've built this explainer as a high-energy, rapid-fire, flashcard-style study guide. We've distilled exactly what you need to know and nothing else, straight from the source material, so we can lock these answers right into your memory. Get ready, because we are going to test you right now.
Okay, let's dive straight into the syllabus. We're covering 1. Hull construction and floors, 2. Gas detection and atmospheres, 3. Fire systems and bottle safety, 4. Pumping and discharge criteria, and finally, 5. Essential maritime acronyms.
All right, Section 1, Hull construction and floors.
Okay, this is the structural foundation of your ship, and honestly, it's the foundation of a strong oral exam performance too. Here's your first classic examiner prompt. Explain bilge keel construction. Where exactly is it located and what's its standard thickness? Think about it for a second. Do you have the exact numbers in your head? Let's see if you nailed it. A bilge keel is a longitudinal structure running right along the length of the ship's hull, and its main job is to reduce rolling motion. It's located right at the turn of the bilge, fitted at a 90-degree angle to the hull. Now, did you remember the dimensions? The depth is between 250 to 400 millimeters, but the really critical number to remember for thickness is 14 millimeters. Look at the floor types below too. You've got to remember the difference here. Bracket floors have those large openings to optimize weight in areas where you just don't need as much strength. Solid floors, on the other hand, are totally continuous. They provide vital transverse strength and are usually placed every 3 to 4 bracket floors.
And right here, this brilliantly illustrates the load line diagram. This is a massive favorite for examiners. You absolutely must be able to sketch and label this from memory. Look really closely at the center, right at the plimsoll disc. You need to look the examiner in the eye and confidently state that its diameter is exactly 300 millimeters. Notice how the line through the center of that disc lines up directly with the summer freeboard draft. Memorize the placement of the tropical, fresh, and winter marks off to the right too. When they ask you to draw this, getting those proportions right, especially that 300 millimeter disc, shows you totally know your stuff.
Moving on. Section 2. Gas detection and atmospheres.
Examiners absolutely love this section, mostly because it's just full of operational trap questions. Using the wrong instrument here, literally catastrophic. So what's the actual difference between an explosimeter and a tank scope? Think about their working principles, and most importantly, what kind of oxygen environments they need to function.
You need to lock these differences into your brain right now. Both work on the principle of a Wheatstone bridge, sure, but that's where the similarities end. The explosimeter measures the percentage of the lower explosive limit, or LEL. Its sensing filament is chemically coated. Because of this combustion reaction, it absolutely requires at least 11% oxygen to work. If you drop it into an inert tank, it's going to give you a dangerously false reading. The tank scope, however, measures the percentage volume of hydrocarbon vapors. Its filament is not chemically coated, which means it actually cools down when exposed to gas. So it works perfectly in an inert atmosphere where oxygen is less than 8%. Explosimeter means high oxygen. Tank scope means low oxygen. Whatever you do, don't mix them up.
All right, Section 3, Fire Systems and Bottle Safety.
Preventing explosions and suppressing fires are your core duties. You need to be fast and flawless here. If an examiner fires this at you, what are the safeties built right into oxygen and acetylene bottles? Can you rattle off at least 5 of them for me right now? Tick them off in your head. 3, 2, 1.
Okay, here's your checklist. You absolutely must mention the flashback arrestor and the fusible plug. You also need to mention the color coding. But listen, here is where you really show your competence, the threads. Emphasize to the examiner that the oxygen bottle has a right-hand thread, while the acetylene bottle has a left-hand thread. It's a foolproof physical design that prevents you from accidentally swapping highly reactive hoses. And lastly, for sure, they must always be kept in separate rooms.
Now check out this complete schematic for the CO2 fixed firefighting system. In the oral exam, you have to be able to verbally trace the path of the CO2, so follow it with me. From the release cabinet, the pilot cylinders are activated. But crucially, notice the time delay unit on the left. You have to mention this. It gives your personnel the vital time they need to evacuate the engine room. From there, the gas opens the master valve, enters the common manifold, and finally rushes out through the distribution pipelines and nozzles. Understanding that exact sequence, release, delay, master valve, distribution, is exactly what they want to hear.
Up next, Section 4. Pumping and discharge criteria.
We are entering MARPOL territory now. The regulations here are strictly black and white. Missing even one condition on this list is an automatic fail. No exceptions. So, what is the exact discharge criteria for an oil tanker's slop tank into the sea? There are 6 strict conditions. Can you name all of them?
Treat this like an unyielding, unbreakable checklist. 1. The ship must be en route. 2. The oil discharge monitoring and control system, the ODME, must be operational. 3. The tanker is not within a special area. 4. You have to be more than 50 nautical miles from the nearest land. 5. This is the crucial one. The maximum discharge of oil content cannot exceed 30 liters per nautical mile. And 6. The total quantity discharged cannot exceed 1/30,000th of the total particular cargo delivered. Drill those numbers into your head. 50 miles, 30 liters, 1/30,000.
Let's stay with the pumping theme for the next flashcard. The pump room on a tanker is an incredibly volatile, hydrocarbon-rich zone. Because of that, the electrical safeties have to be totally bulletproof. So what are they?
To prevent a single catastrophic spark, this room is decked out with intrinsically safe fire detectors. And by the way, that means they literally don't possess enough electrical energy to ignite a spark in the first place. You've also got a high-level alarm in the bilges. There's a fixed gas detection system, constantly sniffing for hydrocarbons. You've got temperature monitoring devices directly on the main cargo pump to stop it from overheating. And finally, a manually activated trip for the main cargo pump. Every single one of these is a non-negotiable layer of defense.
Let's see how all this builds into our understanding of the Oily Water Separator, or OWS. This schematic is just a masterpiece of shipboard compliance. You need to be able to explain the 2 stages. The mixture enters the first stage for gravity separation, guided by baffle plates. Then it moves to the second stage, and you must bring up the coal ester filter here. That's what catches the tiny, stubborn remaining oil droplets. Finally, look at the OCM, the oil content monitor at the bottom left. If the oil content creeps over 15 ppm, that monitor is what automatically slams the overboard valve shut and redirects the flow right back to the bilge holding tank.
Final stretch, Section 5, Essential Maritime Acronyms.
All right, this is our lightning round. The maritime industry practically runs on alphabet soup, and the examiner is going to rapid-fire these at you, so keep your energy high. First up, SOPP. This stands for the Shipboard Oil Pollution Emergency Plan. The core takeaway here is emergency plan. It's the ultimate step-by-step manual your crew executes the very second an oil spill occurs to stop environmental damage in its tracks.
Next is a really dangerous one, BLEVE. This stands for Boiling Liquid Expanding Vapor Explosion. When the examiner throws this at you, they specifically want to hear the phrase expanding vapor. It's the catastrophic failure of a pressurized vessel when the liquid inside reaches temps way above its boiling point, which usually happens because of an external fire.
LEL and UEL. We actually mentioned this a bit earlier with the explosive meter. Lower explosive limit and upper explosive limit. This defines the exact flammable range of a gas. Below the LEL, the mixture is just too lean to burn. Above the UEL, it's too rich to burn. You have to know exactly where your hazards lie.
Now look at the sheer density of everyday compliance codes you're responsible for on this list. You've got ISPS, the International Ship and Port Facilities Security Code. You have SECA, the Sulfur Emission Control Areas. You've got the ISM, SMS, and IOPP. Honestly, if I were you, I would physically pause this explainer right here, grab a notebook, and test yourself on every single one of these acronyms until you can say them in your sleep.
So, we've covered the exact measurements, the strict MARPOL regulations, and the complex mechanical systems you need for the Class 4 MEO oral exam. But I want to leave you with one final thought. Passing this exam isn't just about rote memorization just to make an examiner happy. It's about knowing exactly what to do when a pump overheats, or a fire alarm triggers, or gas levels suddenly spike in a confined space. You know the regulations on these slides now, but are you ready to command these systems when a real alarm sounds? Keep reviewing, keep studying, and I will see you in the next explainer.